Hello everyone. Hello my dear students. I welcome all the fresh faces to the best learning app, the Teacher app. So, I hope all the fresh faces are very much energetic and this teacher platform is ready, is all set for welcoming the fresh faces to our learning platform, that is the Teacher app. Yes, my dear students, after your school studies, that is your 10th standard, now you are stepped into your PUC. That too, you have chosen science subject. It can be PCMB, PCMC or PCME. Yes, what you have done is a best choice you have done, dear students. And choosing science and also being in this learning platform, that is our teacher app, is the best decision you have made. Because students, once you are science students, now you are already a science students, your way of thinking, your creativity, you should always have a scientific mindset, a scientific attitude, I can tell you. So whatever you see around you, so the way you think, so everything you should have a scientific mindset, my dear students. So definitely this teacher platform not only will be helping you with your studies, also it will help you to increase your creative level, to increase the knowledge of science, to have a scientific attitude. Definitely this platform is going to help you, right? And also you know that it is in a affordable price. I am Meghana, your chemistry lecturer. I keep uploading more and more videos of related to all the chemistry chapters, which will be very much helpful for you. Definitely, it will help you in all the ways. So, any concept or any topic you feel difficulty in any level of your studies, definitely through teacher platform, everything is gonna be very easy. Fine. Today, I have brought the very important, the most wanted, I can tell you, the most wanted concept of chemistry, that is organic chemistry. Students, in your school level, you would have studied some basic things about organic chemistry. First of all, you all have to know that when it comes to chemistry, when you're studying in your PUC level, chemistry is divided into three branches, right? You already have this knowledge, I hope. That is, we can study chemistry as physical chemistry, as inorganic chemistry, and also chemistry can be studied. Another branch of chemistry is organic chemistry. I always like to give more importance to organic chemistry because most of the students tell me, they say that ma'am, organic chemistry is really difficult, it is very hard to practice or very hard to remember. Why I'm telling you in the beginning itself, students, because I want to tell you what are the difficulties that students are facing in organic chemistry, why they feel the difficulties, and how to overcome that. Therefore, I have chosen organic chemistry for your first class, and I am here through teacher platform to make organic chemistry easily accessible, very much to make it very easy for you. Okay. So, what do you mean by organic chemistry? What do we study in organic chemistry? You all know that periodic table has arrangement of elements. In periodic table, there are totally 118 elements you can find in periodic table. Out of 118 element, I will choose a major element, that is carbon. So, studying specially about carbon and its compound. Okay, so we study only about carbon and its compounds. We call it as organic chemistry. So, students, just think of it. See, there are totally 118 elements, right? So, out of 118, I'm concentrating only on the carbon and made it a separate branch of chemistry as an organic chemistry. That means how importance I'm giving to carbon. right? That means if I have to give so much importance to carbon, it shows unique properties compared to other elements in the periodic table. What are those unique properties the carbon shows? It shows catenation, that means it can form a carbon-carbon bond. Yes, and carbon has 4 valence electrons through which it shows a property of tetravalency. Carbon can form different allotropes and varieties of organic compounds, right? So we say that in single word we can say that carbon is versatile in nature. So there is a in-depth studies of this carbon compounds. That is a never-ending process, dear students. So therefore we have made it a separate branch of chemistry, and the major branch of chemistry we can call that is organic chemistry. And yes, why students feel organic chemistry as a difficult one? The most important thing that is required to make organic chemistry easy going is the basic knowledge of organic chemistry. Most of the students lack this basic knowledge, and that's why they stuck in between and they feel it is difficult. But for all the fresh faces here, they're listening to my class. I don't want this to happen in your case. So I have brought the videos, and definitely I'll be uploading the videos related to all the basic concepts you have to know in organic chemistry. Once you all are thorough with the basic concept, you are listening to all my classes, definitely it will be a very easy journey of organic chemistry, dear students. Okay. So let me explain in a definition form. How can I explain organic chemistry? It is nothing but it is studying about carbon and its compound. Now, why we have to study this organic chemistry? Why is the question, right? Okay, I will answer for that. Why you have to study organic chemistry? Because students, you cannot imagine your life without organic chemistry. For example, in our daily life, the coal or petroleum from which we get fuel, it contains carbon. Yes, the major component of all the petroleum products is carbon. Correct? You don't have to go till fuel. What is our body made up of? See, the main component, the genetic materials of our body, or it can be DNA. All the genetic materials. What is DNA, dear students? It is nothing but the information is passed from one generation to another. It is made up of carbon compounds. The proteins, it can be the proteins in our body, the blood in our body, or the muscles, all has carbon content or carbon compounds. The proteins are made up of carbon compounds. These are the some natural examples I have given. Along with that, you can take any kind of materials like polymers. What is polymers? Polymers which we use in our daily life, like the clothes. What is our clothes made up of? The bags, the shoes, what you are wearing, the nylon, silk materials, the leather materials, the rubbers. Everything contains organic compounds. That is, in general we call it as polymers, especially in the field of medicines, right? So organic compounds play major role in the field of medicines. Like this, there are lot of applications of organic chemistry. I have just given a few simple examples. There is a more and more lot of examples which we keep discussing in further classes, students. So these are some of the applications of organic chemistry. So, from where it all started, to tell you, the organic chemistry studies is around 200 years old. It has a history of around 200 years, my dear students. Okay. So let me explain the origin of organic chemistry to you all. um, Before, what was the mindset of all the chemists or all the people is that organic chemistry or organic compounds are nothing but those compounds that can be obtained naturally through plants or animals. We cannot obtain or we cannot synthesize any organic compounds in the laboratory. The anything that we obtain from plants and animals naturally were known as organic compounds. Okay, and that we synthesize in the laboratories were known as inorganic compound. So based on this, a scientist known as Berzelius, he said that organic compounds are obtained from a vital force. It was known as vital force theory. He says that some vital force means, I can tell you, some natural phenomenon is responsible for the origin of organic compounds or the formation of organic compounds. That means he meant to say that we cannot prepare any organic compounds in the laboratory. We cannot synthesize organic compounds, where this assumption or this theory was made wrong when a scientist called Walher synthesized first organic compound in his laboratory. So what he did, he he took an inorganic compound, that is ammonium cyanate. So what is this? NH4 C triple bond NO, that is nothing but ammonium cyanate. So he took an organic compound. Through ammonium cyanate he used to get, what he got is urea. So through inorganic compound he synthesized urea in the laboratory. This urea is nothing but it is an organic compound. Okay, the first organic compound that was synthesized in the laboratory was urea, and this was the first attempt that was made. And now you just cannot imagine the growth of organic chemistry. We can synthesize any kind of organic compounds in the laboratory, and the growth is huge. It's very huge, dear students. So understood, you all came to know about the origin of organic chemistry, right? And next we shall discuss about the, now let us come to the exact concept, that is about the carbon atom. Let's start studying about the carbon atom. So you know that carbon, what is the atomic number of carbon, dear students? Yes, the atomic number of carbon is 6. So can you all write the electronic configuration of carbon? Yeah, the electronic configuration of carbon will be 1s2, 2s2, yeah, 2p2, right? So let's try to fill the electrons. You know how to fill the electrons? Through orbitals, that is. So let us take it as 1s. Let me take the outer valence shell, or the outer orbital contains how many electrons? That is, I will represent 2s orbital like this, and 2p, 2px, 2py, and 2pz, right? So now let me fill the electrons. 2s orbital contains 2 electrons, so I fill 2 electrons here, and 2p orbital contains 2 electrons, 1 2, right? So you know that the valence electrons in the carbon is 4. That means it requires another 4 electrons to form octet, correct? But when you observe here, what do you think? Here it has to pair up with 2 electrons and one more is empty, right? So what happens here is, students observe, one electron jumps here to the 2p orbital. So now what you have is, all has single electrons or unpaired electrons you can observe. So observe here. So now how many unpaired electrons you got? Once the electron from 2s jumps to the 2p orbital, now how many unpaired electrons you have, dear students? You have 4 unpaired electrons. So carbon, to pair up or to form the octet structure, it requires 4 more electrons, right? So what it does, what the carbon will do? So it requires 4 more electron. So it cannot take 4 electrons. Instead, it will share. Sharing of electron takes place here. Carbon will form a bond through sharing of electron with the other atoms. Therefore, the what kind of a bond? Through sharing of electrons to obtain the octet structure, the bond that is formed is called as covalent bond. So what type of bond we can observe in carbon atom is covalent bond. See, I told you we are discussing about carbon atom. I cannot call carbon dioxide or any carbonates or carbon monoxide as an organic compound. No, these are not organic compounds. Organic compounds are the one which is formed by sharing of electrons or through covalent bond. Usually, when we talk about hydrocarbons, usually it is carbon and hydrogen atoms. So let us talk about, so you understood about the unpaired electrons, how the carbon atom forms a bond. When carbon atom is forming a bond, the hybridization happens in 3 ways. 3 types of hybridization can be observed during the formation of a bond in carbon compounds. That is sp3 hybridization, sp2 hybridization, and sp hybridization. So in detail, let us study about what is this sp3, sp2 and sp hybridization. So just now I explained about s and p orbitals, right? There is no d orbitals or f orbitals in carbon atom because the atomic number of carbon is 6. D and f orbitals will not be involved, where it involves only S and P orbitals. So in S and P, when one S orbital combines with 3 p orbitals, totally how many, students? How many orbitals? 1 s orbital and 3 p orbitals combine together to form 4 sp3 hybrid orbital. Is that clear? Now, 1 s orbital and 2 p orbitals combine to form totally 1 s and 2 p, means how many? 3 sp2 hybrid orbital. Same way, 1 s orbital and 1 p orbital combine to form how many? 2 sp hybrid orbital. That means, what is hybridization? Students, hybridization is nothing but combining of the orbital. See, if this is s orbital, like if it is 2s and this is 2p orbital, s orbital has different energy, whereas p orbital has different energy. The energy is not same. But to form a compound, to form a covalent bond, what happens? A combination of s and p orbital takes place. S and p orbital starts combining together and form a hybrid orbital of different energy. So hybrid orbital will, the s orbital is having different energy, p orbital has different energy, but when they combine they will have an equivalent energy. Is that clear? So the energy becomes equal. So, and this formation, mixing of the different energy orbitals and to form a new hybrid orbital. Is that clear what I mean to say? Mixing of different orbitals and forming a new hybrid orbital is the process is known as hybridization. And the carbon compounds shows sp3, sp2 and sp hybridization. So what is this sp3, sp2, sp? I explained you, that is 1s and 3p orbitals. If they combine it forms 4 sp3 hybrid orbitals, and 1s and 2p orbitals combine to form 3 sp2, and 1s and 1p orbitals combine to form 2 sp hybrid orbitals. So how this combination takes place, I will definitely explain you. Based on this hybridization, each carbon compound shows a different structure. For example, sp hybrid orbitals shows linear in shape. The compound, the structure of the compound or the shape of the compound will be linear, whereas sp2 hybridized orbital shows trigonal planar structure. So what will be the shape of the sp2 hybrid orbitals? It is trigonal planar, whereas sp3 hybrid orbitals shows tetrahedral structure. Is that clear? So now let me explain you in depth about each and every hybrid or hybridization. Let's talk about sp3 hybridization. Okay. Now you know that carbon atom already it has 2s, 1 unpaired electrons, and 2p, 3 unpaired electrons in 2p. So now it requires 4 electrons to form a octet structure. So now carbon atom is having already 4 valence electrons. It is waiting for 4 more unpaired electrons. Now let's talk about the compound methane. What happens in methane, students? So each hydrogen atom comes to share electron with the carbon atom. Now for example, one hydrogen atom has one electron, and another hydrogen atom has one single electron, another hydrogen atom has single electron, and one more. So these hydrogen atom also requires one more electron to form a stable compound, and carbon also requires 4 electrons. So what happens? The understanding between the carbon and hydrogen, they start sharing electrons. So carbon starts sharing its electron with 4 hydrogen atom. So the hydrogen also attains the stability, and also carbon also attains stability by getting, now you count the number of electrons in carbon, the electrons will be 8, right? So what happened here is the bond between here, the s orbital, so carbon hydrogen will give electrons to the carbon atom here. So the s orbital combine with the 3p. So here you can see it is one s orbital combined with 3p orbitals and form 4 sp3 hybridized orbital. That is, the 4 sp3 hybridized orbital of carbon forms bond with the hydrogen. These are the 4 sp3 hybrid orbitals of carbon that will form a bond with 4 hydrogen atoms. Fine. So what will be the structure of, exactly the structure of CH4? If you observe, it shows a tetrahedral structure like this. So this is the this is, we call it as the tetrahedral structure. So it shows a kind of tetrahedral structure. So therefore we say sp3 hybridization, the structure of the compound will be tetrahedral. See another way, one more simplified way I will tell you to calculate the hybridization. So hybridization can be calculated as number of atoms attached, number of atoms bonded or attached, plus how many lone pair of electrons are there. Lone pair means extra electrons. So if you see the methane structure, one carbon atom is attached to how many other atoms? It is attached to 4 atoms, right? And is there any lone pair in the carbon? Can you find any lone pair? No, there is no extra electrons. All the 4 unpaired electrons are filled. So it is 0 lone pair, dear students. So 4 plus 0, it is 4. 4 means how many? 4 means how many orbitals? It is 1s and 3p. Yes, it is sp3 hybridization. So sp3 hybridization means definitely the structure should be tetrahedral. Now, what about the same way? What about the sp2 hybridization? So, let's talk about sp2 hybridization. For example, let me take C2H4. So, C2H4 means what? 2 carbon atom and 4 hydrogen atoms. So, 4 hydrogen atoms I will fill like this. So if it is 4 hydrogen atom, you know that one carbon should contain 4 bonds. That means only one carbonic acid bond. So the 3 bonds are there. So it is double bond. Right? So this is nothing but alkenes. So here let us count the hybridization. So hybridization means nothing but number of atoms attached plus lone pair, right? This is what I told you, number of atoms plus lone pair. So take one carbon atom. Now this first carbon atom is bonded to how many atoms? It is bonded to 2 hydrogens. Also it is bonded to one carbon here, right? One single carbon atom is further bonded to 3 atoms. So number of atoms, see, the 2 hydrogen atoms and 1 carbon atom. So total 3 atoms, and the lone pair is 0 lone pair. So totally it is 3. 3 means what is the hybridization? Hybridization is sp2 hybridization. Is that clear? So if you see from this, we can make out the hybridization of C2H4 or double bonded compound is sp2 hybridization. That means one carbon atom forms 3 sigma bond and 1 pi bond. If you see one double bond or 1 pi bond, the hybridization is sp2 hybridization. Now same way, let me take ethine. So what is this? C2H2. That means C triple bond C. So in this case, how many, the number of atoms is one carbon atom is attached to 2 atoms, plus there is no lone pair. So therefore the total it is 2. Therefore the hybridization of ethine is sp hybridization. So students, from this it is very clear for you all. What understanding you get is, if a compound, the hybridization of a compound is sp3, then definitely that will be alkanes, or it will be single bonded components. All the 4 bonds must be single bond. That means it will be having a general formula CnH2n plus 2. If all 4 bonds of a carbon is single bond, the hybridization will be sp3. sp2 means if the hybridization is sp2, definitely alkenes will have sp2 hybridization. It has to contain at least one double bond. If there is a double bond, then the hybridization is definitely sp2, and the general formula of alkene I am writing CnH2n. Same way, the sp hybridization is nothing but alkynes will be having the hybridization sp hybridization. That means you will triple bonded compounds will have shows sp hybridization with the general formula CnH2n minus 2. Is that clear for you all, dear students? Yeah. So this is about the hybridization of carbon atoms. And yes, sp3 hybridization means the compound shows tetrahedral structure. So this is the tetrahedral structure it shows. Whereas sp2 hybridization, for example, I wrote CH2, double bond CH2, right? So alkenes, the compound shows trigonal planar structure like this. Trigonal planar structure, whereas sp hybridization compound shows linear structure like C triple bond CH, it shows linear structure. Is that clear? The shape of the hybrid orbitals will be tetrahedral, trigonal, planar or linear based on the hybridization. So further classes will discuss more and more about the hybridization in further coming classes, dear students. So is it clear about the type of hybridization shown by the carbon compounds? Now, when I was explaining the hybridization, you also came to know that the carbon compounds, the hydrocarbon especially, is classified as alkanes, alkenes and alkynes based on single bond, double bond and triple bond. One thing you have to make sure whether it is a double bond, triple bond or single bond, you should see to that each carbon atom has 4 bonds, that is 4 valence bonds. Fine. So based on this, we have to understand what are these bonds, how is this bonds formed, what are the types of bonds. Carbon atom consists of 2 types of bond. One is symbolically represented like this sigma bond, we call it as sigma bond. Other next one is pi bond. You know that S and P orbital will be involved in the formation of the bond, right? So let me explain you about sigma bond. Sigma bond is nothing but if the sp orbitals s orbital and p orbital forms head-on-head overlap. If the overlap of the orbitals, I told you no, hybridization means the overlap of the orbitals or the intermixing of the orbitals is the hybridization. When they are intermixing or overlapping, if it is a head-on-head overlap, for example, if I represent s orbital in like in the form of sphere, two s orbitals combine like this head on head, or one s orbital and p orbital is represented in a dumbbell shape like this. So one s orbital and one p orbital head on head overlap, or it can be two p orbitals also. Two p orbitals overlap like this, that is a head on head overlap. So this kind of overlap of orbitals leads to the formation of bond known as sigma bond. Is that clear? Now, then what is pi bond? Pi bond is nothing but is here the overlap happens sideways, and here s orbitals are not involved in the overlap, it is only p orbitals. So sideways overlap of the orbital, for example, one p orbital overlap with another p orbital like this, or if there is one p orbital of one element, another p orbital, they overlap like this sideways. So this leads to the formation of pi bond. Is that clear? So for example, one example I will give you, then you should be able to identify the sigma bond and pi bond. Is that clear? Now for example, if you take ethene, in ethene you know that it is nothing but sp2 hybridization, correct? So if carbon sp2 means 1s and 2p orbitals, right? Totally 3 sp2 hybrid orbitals you get. In that, one sp2 orbital form sigma bond with the one carbon atom. So this is sigma bond. Another sp2 orbital. So another sp2 orbital. This is sp2 forms a bond with the hydrogen atom. Now another sp2 orbital of carbon forms sigma bond with the hydrogen atom. So this is sigma bond. This is also sigma bond. So here also it is sigma bond. This is sp2 orbital. It is done. Right? Same way for this carbon atom also. It has formed one sigma bond with the carbon atom. Another sp2 orbital of carbon forms sigma bond with the hydrogen atom. So this is sigma bond. So another sp2 hybrid orbital. So form sigma bond with the hydrogen atom. So all the three sp2 hybrid orbital is used here to form sigma bond with two hydrogen atom and one carbon atom. Now this carbon atom still has 2p orbital. The 2p orbitals in will be left over as such. So what happens to this 2p orbitals? The 2p orbital, this is 2p orbital, this is also a 2p orbital, form sideways overlapping. So this sideway overlapping leads to the formation of another type of bond. If this was sigma bond through head on head overlapping, the sideway overlapping of the p orbitals, remaining p orbital, lead to the formation of pi bond. Is that clear? And the same way in case of alkynes. In alkynes there will be one more p orbital overlap to form the one more pi bond. So it leads to the formation of 3 triple bond. So for example, if I give any example of any compound CH3 CH double bond CH2. So how many sigma bonds you can find here and how many pi bonds? For example, if you see all the single bonded carbon between the carbon and hydrogen, all the single bond between the carbon and hydrogen is formed through sideway overlapping. So all these bonds are sigma bonds, whereas the single bond between carbon carbon, this is also through head on head overlap, that is also through sigma bond. And here one bond is through head on head overlap sigma bond, and the another bond that is through 2p orbitals head on sideways overlap lead to the formation of pi bond. So in this case we find one pi bond. So if I write the structure of ethine, C triple bond C. So here you can see between carbon atoms there is one sigma bond and two pi bonds that is formed through sideway overlap of the p orbital. So these are the ways you have to understand. You should be able to count the number of sigma bonds and pi bonds in any organic compound. So if all bonds are single bonds, they are considered as sigma bond. In double bond compounds or in alkenes, one bond between carbon and carbon will be sigma, and the another bond between the carbon atoms will be considered as pi bond. In case of alkynes, between two carbon atom there will be one sigma bond and two pi bonds. Is that clear? Next we have to discuss about structural representation of organic compound based on the arrangement of bonds. I can tell you we can classify the structure of organic compound as condensed structure, complete structure, and also bond line structure. In today's session, let us understand about condensed structure and complete structure. And I'll just give one or two example, and in further sessions definitely we are going to discuss more and more concepts of organic chemistry in detail, my dear students. So what is condensed structure? It is nothing but, if I ask you what is the formula of methane, carbon attached to 4 hydrogen atoms, CH4. Now write the structure. I will write the CH4 structure. I can write like this. C attached to 4 hydrogen atom. Now in this case, the I in depth I have written all the single bonds I have shown here. This structure of methane I can call it as complete structure, whereas writing it in the form of molecular formula in short as CH4, I can tell it as a condensed structure. For example, what is the for ethane, how can I represent ethane? I can represent ethane as C2H6. Then this is called as condensed structure. If I write the complete formula of ethane as CH3 single bond CH3, then this is called as complete structure. And also I want you with you all to discuss more and more about the condensed, complete and bond line structure. You have to wait until I upload the next video. Listen to the complete video for clear understanding of the origin of the organic chemistry and the hybridization. You should be able to find out, dear students, any compound is given to you, you should be able to find out what is the hybridization, whether a compound is sp3, sp2 or sp hybridization. I hope this video is definitely helpful for you. Keep learning in the teacher platform for your successful, and I wish you all the best for your successful journey of the 2 years of your second PUC. Thank you students, thank you all.